Welcome. I'll talk about adding vectors. Now, why would we want to add vectors? Let's look at an example. Suppose that this is me, and one morning I decided to take a walk. So I come out of my house and I started walking. And suppose that I walk and walk and walk, heading towards the direction where the sun rises, heading towards the east, and I walked for 100 meters. Okay, walked for 100 meters, and then I decided to have a change. I decided to look at something different, and so I turned towards the northeast. And I continued walking for 60 meters. Okay, so let's say I walked for 60 meters. Right, so I turned towards the northeast. That means I changed my direction by 45 degrees. Now I can think of my first 100 meter as a displacement. So this displacement, my first displacement, would be 100 meters to the east. So that there are two pieces of information here. Now my second displacement would be 60 meters to the northeast. So that's a displacement too. So I had one displacement and I had another displacement. Now then I can ask the question, what is my total displacement? Okay, well, you might say, right, I walked for 100 meters and then I walked for 60 meters, so my total displacement is 100 plus 60. You would be right if you want to find the total distance. But unfortunately, this is wrong, because we're not talking about total distance, we're talking about total displacement here. So to see how the total displacement is different, let's think about this physically. Let's start by thinking about this physically. So I started here at this point, and I ended up here. Now, if I then, having ended up here, if I then look back and think of what my displacement is after I've walked these two displacements, if I think about what my displacement is when I reach there, I could think of my displacement by drawing a straight line from my start point to my end point. I can do that, and I can think of my displacement as a certain distance in a certain direction, which means which I could describe as a certain angle. A certain angle, I call that theta, to the east, for example. So this would be my final or total displacement. Okay, so physically that's how I could describe my displacement. So you can see from this description that it is clearly not the same as 100 meters plus 60 meters, which is what I would get if I add up this and this. Right? This distance is clearly a bit shorter than just a simple 100 plus 60. So how would I then find this displacement? Well, there are two common ways to do it. A simple way might be to draw a scale diagram. Right? It's a bit troublesome to draw a line that is 100 meters long. You need to walk quite far, and and you need to measure it with a long measuring tape or rope. But it would be easy if we use a scale drawing. For example, I could let 10 meters be represented by 1 centimeter. So I could draw a 10 centimeter line here and another 6 centimeter line there at an angle of 45 degrees, and then I could use my ruler to draw a line joining the start point to the end point, and measure out how many centimeters there is and multiply that number by 10 to get the number of meters of actual distance or actual magnitude of the displacement. And then I can take out my protractor and measure this angle, and I would get the direction as well. Another way to do it, if you have learned about the maths of sine and cosines, if you've learned these topics in trigonometry, you could use sines and cosines to calculate this length. So in either case, we can find the straight line distance and the angle, and that then would give me the total displacement. So if the total distance is d, then my total displacement, the answer or the information about the total displacement would be given by the distance d, which is so many centimeters, and the angle theta, which is a number of degrees. Right. So this then, these two numbers or these two information would then describe my total displacement correctly and completely. So now if I want to think about the idea of adding vectors, if my first displacement is a vector and my second displacement is a vector, I can say that to add these two vectors, the correct way to do it would be to draw these two vectors as arrows, with the tail of one arrow touching the tip of the other arrow. Okay, and then I would join one end to the other end to get a new arrow, and that would be my total. That would be the sum of these two vectors. Okay, now that might seem a little bit abstract. So let me look at, say, another example which might be, instead of displacement, let me look at forces. Suppose that I have, say, a stone. I have a stone here, and suppose that suppose that this is a really big stone, and I tie, let's say I tie a piece of rope to this, and I have one person pulling this with a certain force of I'll just say 5 meters, right? Not too big a force. And let's say I can't move it with 5 meters, and I've run out of strength. So I ask my friend to tie another rope to this, and stand sort of there, okay, and pull together with me. And suppose that my friend exerts a force of 10 newtons. So, well, we can't exactly pull in the same direction because my friend is quite big, so he has to stand sort of sideways, and it ended up that the two ropes that we are pulling with make an angle of 60 degrees in between them. Right, so now I have the two forces, and forces are vectors, as I've mentioned, and I would like to know the combined effects of these two forces. In other words, I would like to add these two forces, but I can't just take 5 plus 10 because they are going in different directions. If 10 and 5 newtons were going in the same, by the way, Newton, this is the symbol for Newton, which is the unit for force. So we'll talk more about that later, but for now, just take these as these numbers to mean to be quantities that tell us how big the forces are. So there are 5 units of forces here and 10 units of forces there. And I want to know what the combined effect is. I want to add those two vectors. So how would I do it? Well, as we would use this same method. We would use this same method. And in order to use this same method, what I could do is this. Now, I need to draw, as I described for the previous method, I need to draw those two vectors so that they are head touching tail. Alright, so let me start by drawing this vector separately. Let me draw that vector here. Okay, so that's my 5 Newton line. All I did was to copy it down here. Now when I copy a vector, I must be careful to draw it in the same direction. So I mustn't just draw the right magnitude, I have to draw this right direction as well. Of course, this is a rough sketch, so you can just draw it roughly. Now, then about the other vector, I need to draw the other vector so that the tail of this arrow touches the tip of the first arrow. Okay, so I would draw this vector here, like this. There. So that's my 10 Newton force. And I must make sure that it's pointing in the right direction. Now, but how do we determine the direction? We always need some reference direction, and in this case, let me take my 5 Newton as the reference direction. So I know that the 10 Newton has to be at 60 degrees to the 5 Newtons. So I can, on this new picture, I can indicate it this way. Let me just extend this 5 Newton arrow a bit longer with a dotted line, and let me mark out this angle here as 60 degrees, right, since this is clearly the same angle as that. So once I have this, I can now take over the method I used for previously for my little morning walk, and I can now draw the sum of these two vectors by drawing a straight line all the way from the tail end to the tip of the other arrow. And so that is the sum or the addition of those two vectors, which is the same as those two vectors. So I can, like I described, for example, do it by a scale drawing, like by drawing a line of say 5 cm here to represent 5 newtons, 10 cm to represent 10 newtons at this angle, and then use a ruler to measure the resulting line, resulting number of cm of this line to determine its magnitude. So having found this resultant force, I would need to know the direction as well. So let's say this direction is given by the angle alpha. Okay, so together this number and this number would be my answer, would be the resultant, the combined effect of those two forces, which I could draw here. So that would have the magnitude of F that I could work out here, and the angle alpha that it makes with the 5 Newton force. So before I finish off, let me just mention another way of adding vectors. So what I've described there, as you can see, always gave me a triangle. So we call this the triangle law of addition of vectors. Now there is another way in which, instead of drawing the two vectors head to tail, or tip of the arrow to the tail end of the arrow together, I can draw them tail to tail, or end to end. Okay, in which case, instead of having a triangle, I would take these two arrows to be the sides, to be two sides of a parallelogram. And what that means is that I would then complete this parallelogram by filling in the other two sides. So this side will be parallel to this side, and that side parallel to that side. Now, the moment I complete the parallelogram, you can see that the resultant is clearly the diagonal, all right, or the line joining the opposite corners from the tail ends of the two arrows to the opposite end. So we call this the parallel, or let's get this right, parallelogram law of addition, of vectors.